Hi everyone, welcome to today's lesson about similarity, stage 5.1 work. Today's learning intention is to solve problems using ratio and scale factors in similar figures. And this is the list of things that I'd like you to be able to do. First of all, similar figures have identical shape but different sizes. Corresponding angles are equal in size. And corresponding sides are in the same ratio, which is given by the scale factor. It's really important to understand this is the symbol that we use for similarity. Okay, so we could replace this symbol with these words. Is similar to. The scale factor is the length of the image over the length of the object. So for these triangles here, ABC, this triangle, the green one, we have a length 3 here, we have 4 here, and we can work this out to be 5. So ABC, the green one is our object, and the pink one is the image. So 3 here is in the same position as 1, 2, 3, 4, 5, 6. So we've got 6 here. So 6 over 3 is 2. That's our scale factor. So A dash B dash equals 6. The dashes indicate that the pink one is the image. So 6 over 3 is 2. So our scale factor, image over original, so size of the image, size of the original is 6 over 3. So our scale factor is 2. The note here indicates that we could use any pair of corresponding sides to work out the scale factor. So 1, 2, 3, 4, 5, 6, 7, 8 for this length. 8 divided by 4 is 2 as well. This one here would be 10. 10 divided by 5 is 2. And that's what we call the scale factor. Example 2, enlarge the shape below by a factor of 3. So that means that this distance here, 4, we times by 3. So in our image, this side will be 4 times 3, which is 12. So you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This side's 12. This one's 3. And 12 divided by 4 is 3. You can see here for the note, I want you to notice that JF, which is this line from J to F dash, is 9. And JF equals 3, so here to here is 3. 3 3s are 9, so our scale factor is 3, and we've enlarged the shape. So to do that, see this line here, if we draw a line from J out to F and extend it, we can measure 3 here and 9 for the total. We can do the same thing for all of these points. We can draw a line through the corners to the center, or this point can be moved around. We can measure this distance and times it by 3. Example 3, we can also solve similar problems to trigonometry. A 1.5 meter pole, so if we have a pole that is 1.5 meters tall, casts a shadow that's 3 meters long, find the height of a building that casts a shadow 15 meters long at the same time of day. So if this is 3, if we have a building that's 15, we can find the height. Better diagram is this one. So you can see here that we've got 3 and 15. So we can use that to find the scale factor. So the scale factor is 5. And then we can times 1.5 by 5. Scale factor is 5 and times that by 1.5. The height of the building is 7.5. You can notice that you can get the same answer by working out what to times 1.5 by. So if we double 1.5, we get 3. So then this height, we know 15, so we can divide that by 2. 3 divided by 2 is 1.5. 15 divided by 2 is 7.5. Both methods work. For example 4, we need to find the value of x. X is this one. This side is 8. This side is 4. And this one is 6. So from a problem solving point of view, you can work out that 4 2s are 8. So 6 2s are 12. We need to times 6 by 2. So find the scale factor and then use it. Or you can use this method here. I actually like the ratio of sides method because it does allow you to solve harder problems. So to do that, this is where we say x over 6 equals 8 over 4. And then we solve this equation by moving the 6 over to this side. We multiply both sides by 6. Both methods we get 12. Both methods are good. So for example 5, find the value of y. So y is here. And you can see that I've got blue matching blue. So the blue ones are corresponding. 6 and 3 are orange, so they're corresponding. So again, we can find the scale factor. 6 divided by 3 is 2. Okay, but this time around, when we find y, we actually need it to be half of 4. So 6 divided by 2 is 3. 4 divided by 2 is 2. This is why I like to use ratio of sides. You could divide by 2. This way you don't need to worry about the scale. So change that to y so it matches the diagram. Y, so the blue line on the object, over 4 equals 3 over 6. So match the sides up. These two are the corresponding sides. Start with the thing that you're looking for. Y over 4. We started with a smaller triangle, so 3 over 6. Solve the equation by multiplying both sides by 4. So y equals 2. just make sure that it makes sense. So we've got 2 and 3 on our smaller triangle and 4 on 6. So you can check it with the scale factor. Make sure you've halved or doubled the right side. Just make sure the answer makes sense. Okay, you can try these questions to practice your skills. Good luck. Let me